Okay, good evening, friends. Welcome to the first class. So this is going to be physics revision class unit wise. Okay. So according to me, the physics revision classes, regarding the physics revision classes, the unit wise revision classes are the best way to revise the theory and also to do the questions. Okay. So when we do unit wise revision classes, usually how we go is, so I will quickly brief you about how these sessions will be conducted. Okay. So first thing, so each unit, we will revise the theory. Okay. So we are going subunit wise. Okay, subunit wise. So if you take mechanics for this week, we are going to revise the linear motion. Okay, so linear motion, which means the kinematics. So we'll be revising the linear motion part, and we will also be doing the questions from that particular subunit. So I basically use Pesuro Publications books. Okay, because it has MCQs from 1992. Okay, 1992 to 2016. I mean, the latest, I think latest books may have up to this year, but the books that I have only have up to 2016. So we can do the other years also by just looking at the paper, because we all have those papers after 2016. But from 1992, most of us don't have papers. So it's better to have that MCQ compilation book. So I made all the PDFs. Okay, I made all the PDFs, and PDFs will be shared before that unit starts. Okay, and then we will also be discussing some of the essays and also structures. Structures means mainly practicals will be discussed. You all know the structure part. And essays I will be discussing only some of the selected essays, because discussing everything is not possible, because we have only a limited time. Okay, and the classes will be held on Saturdays from 6:30, Sunday also 6:30. Okay, 2 days 6:30. So we can make some adjustments after this week. I will give you a Google form so that we can make some adjustments in order to get maximum attendance, because you will have different schedules. So by considering the majority, we can have a new timetable maybe, if it's possible. And when it comes to revision classes, it is about practice by you. Okay, so I'm just a guide. I will help you to revise the chapters, but it is mainly the hard work by you. Okay, so today, make your mind to work so hard, to work very hard, and also at the same time smart. I will tell you the ways to work smart. So this is the smartest way that I have ever done when I was a student, and also when I did the paper classes. This was the best way. And last year when I did for Tamil medium, most of the students gave us very, fantastic feedbacks. Okay, so this is the best way to go. Okay, so you will understand, like if you have made up your mind, you can make maximum use of it by working hard. Okay, so I advise you to take a notebook. Okay, to take a notebook and also printouts or the hard copies of the Pesuro publications past papers. Okay, past paper collections. So if you have them already, that's good. If you don't have them, it's not available, I think, these days. So you can get photocopies of the PDFs that I send you. And also, you should write explanations to MCQs. This is the most important thing. It's not about getting answers, it's about understanding how those answers are derived. Okay, so you should have that understanding to answer the new MCQs that are going to appear in your paper. You will do a new paper, no fresh paper. Okay, so that paper will have new questions. So you should have that instinct. Okay, you should have those instincts coming up so that you can get ideas for each question. So that is obtained through excessive, okay, practice. You have to study abnormally, not like a normal student. So when you do such a hard work, such a smart work, you will be able to get that instinct to answer each and every question correctly. Okay, so that is the briefing part. So let's move on to our class. You can unmute yourselves when you are talking, but otherwise it's better if you can make yourself muted. So now I hear a noise. So just check whether you are muted. So let's see how many students are there. So now there are 9 students. Okay, Shana. There are 9 students. I will also be giving the recordings for the students who couldn't attend the class. Okay, and also I will upload it to YouTube. So even if I delete the Zoom recording forever, you can watch the YouTube recordings if you want. Don't waste the time watching it again and again. Once you have extracted all the necessary information and the knowledge from one particular video, you can just go on to the next lesson. Don't repeatedly watch it and waste your time. Okay, so you should finish it then and there, and it's advisable to finish it during the class. Okay, don't postpone the things. So put the heading linear motion. Linear motion. So I'm going to explain some of the theories first, and we will be doing relevant questions. So linear motion, the word itself says its definition. So linear motion is a motion that occurs in a straight line. Simply putting, we can show it in this diagram. Okay, so here there is a block. Okay, and this block is moving in this direction, and it's moving in a straight line. Then this will be considered as a linear motion. Okay, so in this particular chapter, we are going to study the linear motion with a constant acceleration. Linear motion with constant acceleration. Okay, linear motion with constant acceleration mainly. Okay, so before starting this linear motion with constant acceleration, we shall just introduce some of the terms that we are going to study here. So I will go from very basic. So use this time to revise the things. If you have theory doubts, you can ask me anytime through my WhatsApp. So finish the theory, otherwise you will postpone it until your final exam comes. Okay, so revise it. Go to your exercise book, go to your notes and revise it. Okay, so I'm going from the very basic. So first, displacement. So can someone define me what is displacement? What is displacement? So let's say there is a point O here. So this object is here. So displacement is the shortest distance of that particular object from a particular point considered. For example, here the displacement from O is this shortest distance. Okay, you don't measure the distance like this in curved paths. You just draw a straight line connecting these 2 points, and if you measure the length of that line, that will give you the displacement. Okay, and also this displacement is a vector. It always has a sign. It can either be plus or it can be minus. Okay, so let's explain that also. So here I am measuring displacement from O. So here the positive displacement, I am taking an example. Okay, let's say the positive displacement is in this direction. The left side of O, this point O, the left side of the O is negative direction. We should understand this very carefully. Sometimes some students say that when it goes to this side, okay, they consider the movement. When it goes to this side, okay, it's positive. When it comes back, they say displacement is negative. That is not the direction of displacement. The direction of displacement is the position relative to the point considered. So if it is right side, it can be moving in this direction. It can be moving in this direction. Whatever the direction, if the position is right side, then that is plus. If it is in the left side, then that is minus. Okay, that is negative. So that is how the direction of displacement is measured. So when we study the displacement, sometimes we talk about the rate of displacement. Okay, rate of displacement. So that is the displacement occurring per unit time. Okay, for example, So delta is a symbol used for displacement. So delta S divided by time. So displacement change divided by time is rate of displacement. That is called, that is called, is it a very difficult question? That's called what? Okay, I will call you by names and ask. Okay, then yeah. Mariam Rifki she says that it's velocity. Yeah, exactly. Velocity, not speed. Okay, it's velocity. Velocity. So velocity again, velocity is a vector. Okay, velocity is also a vector. So it will have a magnitude and also a direction. So it can also be expressed as plus or minus. Okay. So here you have to consider the motion. Okay, not the side. For example, here this is O. Here we don't consider any point. Okay, we don't consider any point. If it is moving in this direction, if we say it is positive, if the object is moving in this direction, we will say it's negative. In this side, if it is moving in this direction, is it positive or negative? Unmute and say, because I can't come and check the chat. Okay, just unmute and say. If it is moving in this direction, this side of O, okay, what will be the direction of this velocity? Motion is towards the right side. So I have already taken it as plus. So even if it is in this side of O, we don't consider O here. We just see the motion. Motion is towards the right side. So here the velocity is in the positive direction. In this direction, it is negative. In this side, this direction is also negative. Okay. So here we consider the direction of the motion. It is about towards. Okay, towards or away from what? This is about the motion, but this is about position. Okay, don't confuse those two. Okay, so this velocity is the rate of change of displacement. Another thing is there, that is rate of change of the velocity, that is called, we all know that, yeah, acceleration, right? Acceleration. So it will tell you per unit time how much change occurs in the velocity. Okay, so that is how it is explained. Okay, so clear up to now? Any doubts? Okay, so this direction thing will come when we do a question. Okay, so it is in 2018. When we do that, you will understand. Okay, so then we shall move on to the linear motion with constant acceleration. So constant acceleration means constant rate of change of velocity. Okay, constant acceleration means constant rate of change of velocity. So I'm going to plot the velocity of an object against time. Okay, so it starts from my initial velocity of u and it attains a velocity of v within the duration t. So here the time is 0 and here the time is t. So this duration is t. So from this graph, we should be able to obtain the equations for this linear motion. Okay, for this linear motion. So let's try to obtain. Okay, let's try to obtain equations. So now just tell me, this line will have a gradient, right? Will have a gradient. Any graph will have a gradient. So what is gradient? Can you tell me a general definition for gradient or general equation for a gradient? Let's ask. Okay. So Isra, can you tell me the general equation for the general equation for any graph? What is gradient? Have you studied like y difference over x difference? Yes, you would have studied. No, y difference over x difference. Okay, in secondary mathematics we studied that. Okay, So we all know that the y difference over x difference is gradient. And we also know that this gradient is the acceleration, because the y difference will give you the change in velocity. X difference will give you, this x difference will give you time duration. So y difference divided by x difference will give you what? Acceleration. Okay. So first equation that I'm going to derive is for acceleration. So acceleration is equal to the y difference. So y difference means from this value, if you subtract this value from this value, you will get y difference. So that is v minus u divided by x difference. So difference, this is 0, this is t, so difference is t. So now let's make v a subject here. So if you send t to this side, t will multiply, so it will produce at, and v is equal to u plus at. If you send u to this side, it will become plus u. So v is equal to u plus at. So this is the first equation that we derive. So now tell me, what can you tell about the area of this graph? What is given by the area of this graph? Hmm? Tell me. You don't have to worry about your answers, because nobody knows anyone here. Like, people don't know you. Or you can come with a nickname if you want. But I want you to answer. So can you tell me? Oh, Sajida, okay. You're going to tell. What is given by the area? It is displacement, right? The area of the graph will give you the displacement. Okay. So displacement, it will be equal to the area. So area, this is actually a trapezium. Okay, these two are the two parallel sides. So what is the equation for area of the trapezium? Half into sum of the parallel sides. So v plus u into the perpendicular height. So this is the perpendicular height. So that is t. Okay. So s is equal to v plus u over 2 into t is another equation that we obtain from this graph. So now these are the only two equations that we can obtain from this graph. From these two, we can derive more and more equations. How are we going to do that? So first, for v, you are going to substitute u plus at. So if you put u plus at here, okay. So let's do that substitution. So s is equal to, for v, you are going to put u plus at, and again there is a u, okay, divided by 2 into t. Okay, so now there is 2u, okay, divided by 2, it will be u, so it is actually h equal to ut plus half at square. And also, if you substitute for t, so t is equal to v minus u over a, no? Yeah, if you make t a subject, t is equal to v minus u over a. So if you put that here, you will derive another equation, v squared is equal to u squared plus 2as. Okay, so that's the fourth equation. So you have totally 4 equations. So one v is equal to u plus at, the other one is s is equal to v plus u over 2 into t, the other one is s is equal to ut plus half at squared, and v squared is equal to u squared plus 2as. Okay, so these are the 4 equations that we derived from this graph. So we use these in different occasions. Okay, so one instance is you can use it as a motion under gravity. Okay, free fall. So going up, both can be considered motions under gravity. The other thing is motions along inclined planes. Okay, the other thing is normal linear motions. You can freely use these. Okay, and also for projectile motions, you can use. Projectile motion is when you give a vertical velocity and horizontal velocity, the object will travel in this direction. So this is called a projectile motion. So here it is combination of a vertical motion and also horizontal motion. So when we use the equations, we have to mention whether you are using it vertically or horizontally. Okay, so these are the basic things. So what should you do? You go home and revise these and uh, some exercises from your notebook. Okay, so I am going to give you a question now. Okay, so let's do the first question from linear motion. Okay, take the past paper collection that I gave you. Take the past paper collection that I gave you. So it says that first question, an object is projected upwards with a velocity of 100 meter second minus 1 from the ground. If the air resistance is neglected, so the only force acting on the object will be, if air resistance is neglected, only force acting on the object will be what? Any answers? The only force acting on will be mg. Okay, so it is a motion under gravity. Okay, so if the air resistance is neglected, it will strike the ground. So it will go up and rest and come back and will strike the ground. Okay, so in how many seconds? So what is your answer? Anyone? You can put the answers in your chat. You can put answers in chat box. There are 6 messages. You are active than I thought. Yes, good, good. There are. Yeah, wait. 20 seconds. Very good. So this can be done very easily, you know. So here you are sending it with 100 ms minus 1. Okay. So you know that it will go and at a highest point, its velocity will become 0 and then it will come back. So everything happens under the influence of the weight. So that the only acceleration or deceleration that the object will have is g. How to see that? Yes, shall we use f is equal to ma for this? So let's use f is equal to ma in this direction when it goes up. So f will be mg in this direction. So we put minus mg because the direction of force is opposite to the direction that we consider. So minus m, okay, minus m g is equal to ma. So m cancelled out. So a equals minus g. Okay, okay. So a is equal to minus g. So when it goes up, the deceleration is minus g. When it comes back, the acceleration will be g, because in this direction, the mg will be supporting it, the motion. So it will be an acceleration. When it goes up, it will be a deceleration. So we all know that the gravitational acceleration is 10 ms minus 2. Okay, 10 ms minus 2. So it means that, what does it mean? So that's why we study definitions. For every second, there will be a change of 10 ms minus 1 velocity. So every second, there will be a change of 10 ms minus 1. When it goes up, the velocity will decrease by 10 ms minus 1 for each second. When it comes back, the velocity will increase by 10 ms minus 1 each second. Okay. So when will it come to rest? When will it come to a zero velocity? That's what you have to see. Okay, so it starts its motion with 100 ms minus 1. So each second it becomes like, decreased by 10. So 100 becomes 90, becomes 80, becomes 70, becomes 60, 50, like that. 10 seconds. Okay, 10 seconds. So 10 seconds to come here and 10 seconds to go back. Only with mind. Don't have to write anything. So 10 seconds to go to rest and 10 seconds to come back. There is no air resistance. Okay, so that it's totally 20 seconds. If there is air resistance, it is not predictable actually. If there is air resistance, you can't say that going and coming back will be like symmetrical motions. They cannot be symmetrical if there is air resistance, because there will be reduction in the kinetic energy and it will lose its velocity in a very kind of a weird way. The air resistance behaves very unpredictably. Okay, so that has different concepts. So that's why we neglect the air resistance. Okay, so when there is no air resistance, the only force is our mg. So the motion will be symmetrical. Here with deceleration 10 ms minus 1, here acceleration 10 ms minus 2. Sorry, 10 ms minus 2. So you have to do these questions like this. Okay. Okay, I'm going to give you another question. Okay, another one. So if I am okay, um, yes, I can quickly give it to you. So can you actually write it down? Okay, not the words and all. I have to just draw the picture. Okay, so just draw a building like this. Okay, and somebody is throwing it from here, and another identical object from here. So it is thrown with a. Okay, excuse me. Okay, so one is thrown at a velocity of, uh, you know, give me a second, give me a second, give me a second. Yeah, one is thrown u2, and this is thrown upwards with a velocity of u1. The height of the building is h. Okay, it's a past paper question, but you will not see it anywhere because it's all syllabus. Okay, so you have to go to the paper because it's not printed in past papers. And both particles meet at height of h by 2. Okay, so that thing you have to write down. Both particles meet at a height of h by 2 from the ground level. Or from there also it will be h by 2, no? The total height is h. So which of the following expressions are correct? So I will write the expressions because it is an MCQ. So u1 squared minus u2 squared is equal to g squared t squared. Second, u1 squared minus u2 squared is equal to 2gh. Third one, u1 minus u2 is equal to half gt. Fourth one, u1 minus u2 is equal to 2gh. Fifth one, u1 minus u2 is equal to gt. Okay, we have enough time. Try it. You can put the answer in the chat box if you have found out the answer. Okay. So in the equation you have what? You have velocities, u, g, t. Okay, h is there in one of the equations. They have to think about the equation that would relate these things. Take a screenshot, okay? Then I will erase it. Any answer came? Yeah, two answers have come. So one person has given fourth answer and second answer. Is it like that? Okay, she has corrected it. So final answer will be taken as second answer. One person has given second answer. Anyone else? Okay, I'm going to erase it. Huh? Okay, so now there is h. Okay, h is related and t is also there in the equations. So u initial velocity is also there. Final velocity is not there. So the equations with final velocity are out. V is equal to u plus at out. V squared is equal to u squared plus 2as out. S is equal to v plus c over 2 into t out. Only equation left is S is equal to ut plus half at square. So what do we know? We know to write equations for each particle. Okay, let's take it as A and this as B. So this as A and this as B. Okay. So first for A, I'm going to write for A. So in the upward direction, S is here they meet, no? So h by 2 is equal to ut. So u1t, okay, plus half. A is what? A is g or minus g. What is A? Minus g, right? Minus g. Because A is always in this direction. Upward it is deceleration. So it's always minus g into t square. Okay. So finally you get this u1t minus half gt square. Okay, taking this minus before it. And then the second equation for B, I'm going to write downwards S is h by 2 until they meet is equal to downward again u2t again plus half. Here g will be plus, no, because he's moving downwards, so g will be plus, so t square. So this is equation number 1, this is equation number 2. So now we have to solve these two and we have to see whether we can get some equation in the answers. Okay, so naturally one person will tend to add these two. Okay, if you add these two, what will happen? 1 plus 2, if you add these two, h by 2 added, it will be h. And this will be u1 plus u2 into t. This will be added now, so t is a common factor. So I put u1 plus u2 into brackets, and these two will cancel out. So this is a correct equation. Is it there in the answer? No, not there. So this is not the answer. Another person will tend to do another thing. They may equal these two because it also has h by 2, it also has h by 2. So this equation is equal to this equation. So that person will do u1t. So 1 is equal to 2 is the idea that they use. 1 is equal to 2. So u1t minus half gt squared is equal to here u2t plus half gt squared. Both are equal. And now you can take it to this side. So you will get u1 minus u2 into t by taking t as a common factor. If you send it to that side, you will get minus, will add this with half plus half 1. So just gt squared. Okay. So is this there? Yeah, you can cancel this one of the t's. Okay, this t into t, no, this is t. So one t cancelled out. So u1 minus u2 is equal to gt. Is it seen anywhere? Yes, in the fifth answer it's there. Okay, in the fifth answer it's there. So the correct answer is the fifth answer. Okay, so this is how these things have been used in exams. Okay, are you all clear? Any doubts? You can ask any doubts in the chat box. You people are extremely shy. Okay, any doubts? So I will take it as no doubts. Okay. Okay. So what shall we do now? Huh? We have finished it. So now we are going to study a new theory. Okay. So this is the main part of today's lesson. Okay. So now we are going to study about the graphs. Okay. So every year you will get one or two questions from the graph. So directly in linear motion, you get graph questions, and the graphs theory will be used anywhere in physics. Okay, it's used everywhere. Okay, we take electric field, it's there. Okay, everywhere it's there. So the graph theory should be understood very clearly. Okay, so today what I am going to tell you is very important. So listen to me carefully when I explain. Then you will be able to convert the things. Okay. So now we are going to study about converting the ST graphs to VT graphs. So that is the main thing. No? You know to interpret graphs. Usually we all know to interpret graphs. When it comes to the conversion, the confusion arises. So that I'm going to teach you how to convert ST graph into VT graph. And we will also convert VT graphs to ST graphs. Okay. So let's study some graphs. Okay. So I'm going to draw a very basic graph here. This graph is used universally to explain the graph theory. Okay, so I'm also using it. Okay, this simple graph. The origin is not important, just let's study the shape of the graph. Okay, so in this graph, this is a ST graph. So initially there is some displacement, after some time there is some displacement, and this is a straight line. Okay, so it took some time, no, it took some time. So as you all know that this displacement time graph will have a gradient. So that gradient of ST graph will give you what? The velocity. Okay. So gradient of ST graph will give you what? The velocity. It will give you the velocity. So if you can comment about, if you can just explain about the gradient of ST graph, then you will convert it to VT graph very easily, because the gradient of ST graph is the velocity. Okay, so the conversion becomes easier when you understand that the gradient is the velocity. So what is the equation for gradient here? To take, this is y difference, which is displacement difference. This is time difference, which is x difference. So as you know, the gradient is what is usually denoted as m is equal to the x difference, sorry, y difference divided by x difference, isn't it? Okay, so in this particular triangle, okay, this y difference can be seen and x difference can be seen. So let's start, let's focus on this triangle. Okay, so it is a right angle triangle. Let's take this angle. This angle is theta. Okay, so what is delta s over delta t here? Can you write them relative to the angle? Is it sine theta or cos theta or tan theta? Relative to angle is delta s is opposite side. Delta t is adjacent side. So opposite side over adjacent side is actually tan theta. Okay, tan theta. So actually what is gradient? Gradient is the tan value of this angle. What angle? The angle that this graph makes with this horizontal. Okay, the angle that this graph makes with the horizontal. So in this point, if you want to find out the gradient, what should you do? you have to draw this horizontal line and you should take the theta, and the tan theta is the gradient. So now you have two definitions for gradient. One is the y difference over x difference is gradient. The other thing is the tan theta is gradient. Okay, understood up now? Clear? Okay, so now for this gradient, we are going to talk about only two things. Only two things, okay? Only two things. One is the sign of the gradient. Whether it is positive or negative is discussed here. Okay, whether positive or negative. The second thing is the variation of the gradient. It can be gradient increasing, it can be decreasing, it can be constant. Okay, be constant. Okay, so you should note it down. These are the two main things that we will use. First is sign of the gradient, the other one is variation of the gradient. It can be increasing or decreasing, or it can be constant. Okay, so now let's have a look at some of the examples. Okay, so I'm going to erase it. So the first example is our universal one. Okay, so this is ST graph. Now tell me whether this gradient is positive or negative. Is it positive or negative? What do you think? How do you identify whether it's positive or negative? Huh? Can you tell me, Ada Sara? Huh? Can you tell me whether it's positive or negative? Okay, so here you have to consider this angle. So this angle is theta. So that is the the tan theta of the angle is the gradient. Okay, so we have to see whether this tan theta will be plus or minus. Remember, for acute angles, the tan theta is plus. Okay, for acute angles, the tan theta is plus. Give me a second. Give me a second. Hello. பெரியம்மா கிளாஸ் ஒன்ல நினைக்கிறேன் ஒரு 8:30 போல முடியும். ஓகே okay, so this theta, okay, so tan value, whether it's positive or negative, is the thing that we have to see. So here always for acute angle, remember acute angles, the tan value is usually positive. It's taken as positive. So here what is the sign? Positive. And let's talk about the variation. So in variation you have to tell whether it's increasing or decreasing. Okay, so here if you take the angle here, it's theta. Let's take the angle here. Will this be theta or different? What will this be? Will be theta or a different angle? That is also theta. Okay, so you know, no? So there are two lines and the line drawing these two are corresponding angles, the grade 9 stuff. Okay, so you all know that. So these two are equal. So if this is a straight line, these two angles are equal, so their tan values are also equal. Okay, so here the gradient is not changing. Point to point, the gradient is constant. So here positive gradient and also that gradient is constant. So these are the two things that we derive from this graph. And now let's try to draw the BT graph. Okay, so for this ST graph, the VT graph would be, so no, the gradient is positive, so the velocity is positive because velocity is the gradient is the velocity. Okay, so is positive and it's constant. So in the positive side of the graph, you draw a constant velocity. So velocity is not changing. Okay, so this is how this conversion is done. Okay, this is how this conversion is done. Gradient is positive, it's constant, so it is drawn like this. Okay, so let's talk about another example. Draw it in your notebook. Okay, draw it. Let's talk about another example. So what about this one? So just tell me in the chat whether it's positive or negative. Gradient is positive or negative, increasing or decreasing or constant. Tell me that particular thing. You can tell positive or negative. You have to tell positive or negative, and then you should tell whether it's increasing or decreasing. Yeah, it is negative. It is negative. So what about the variation? Negative and constant. Perfect. Variation decreasing. Okay, so this is the confusion usually. Here the displacement decreases, but you have to see whether the gradient decreases or not. The gradient is what? The tan value of the theta. Okay, so here let's try to find out the theta here. So this is the theta. Let's try to find out the theta here. What do you think about these two thetas? Same thetas, right? Same thetas. Because here also it is straight line. If you draw these two horizontal lines, those two will be parallel. So these two angles will be corresponding angles which are equal. So this is theta and this is theta. And theta is not changing. At any point, if you draw a horizontal line, the angle made with the horizontal line is theta. So will the tan theta change? For a particular theta, there is a particular tan theta. Okay, so here it will not change. But what about the sine? You said, all of you said negative. Why? Because we said that for acute angles, the sine is positive. For obtuse angles, okay, the sine is negative. Okay, and also here it's constant. So negative and constant. So how will we draw? How will we draw? VT. So here in the negative side, you have to draw a constant graph, right? Negative side, you should draw a constant graph. Okay. The negative side, you will draw a constant graph. Yes. Okay, clear? You have to find out the variation. The displacement is decreasing, but rate of decreasing is not decreasing. The gradient is not decreasing. It's a straight line. So you can remember like this. For a straight line, the gradient is always constant. Put a note. Put a note. For straight line graph, the gradient is constant. For curves, the gradient will vary. This curve, the gradient will vary. But for straight line graphs, the gradient is constant. Let's move on. So what do you think about this one? So this particular one is famous. Okay. So now try whether you have to tell whether it's positive or negative, whether it's increasing or decreasing or constant. This is a little bit tricky. I'm looking for the answers. Okay. What do you think about the gradient? What do you think about the gradient? Yes, one answer came. Yes. So here you have to look for the angle that is made with the horizontal. This line itself is horizontal. Okay. So the angle made with the horizontal is 0. So for 0, the tan 0 is also 0. Okay. Tan 0 is 0. So here the gradient is 0. Gradient is 0. 0, it's not increasing or decreasing. It's 0, 0. It's just 0. So when you draw VT graph for this, so you just draw the line just to superimpose over the axis. Okay, so just you put it on the axis. So what do we do is we darken the axis. Okay, so people will understand, the examiner will understand that you know that it is 0. Okay, you just darken the axis. So that is 0. Okay, so that's about 0. So here, remember some little MCQ ideas. You can use it here and there. Okay, so then it will be like easy for you, time saving. So here, I already told you one MCQ idea. What's that? Straight lines will have constant gradients. Okay, here, what is the MCQ idea? Here, MCQ idea is the graph that is parallel to the x-axis. So this graph is parallel to the x-axis. If the graph is parallel to x-axis, gradient is 0. Okay, gradient is 0. So that is another MCQ idea. So whenever you see the graph becoming parallel to the x-axis, then you say that there is 0 gradient. Sometimes the graph is like this. Okay, so here you see a parallel point, here you see a parallel point. So in this particular point, the gradient will become 0. Okay, so whenever you see flat parts, then you can see the 0 point. Okay, so 0, 0 gradient. Okay, so now what about this one? Tell me whether it's positive or negative and increasing or decreasing. Yes, yes. Gradient increasing. What about the sign? Yeah, positive and increasing. Very good. Excellent. So here, this is a curve. It's not a straight line. So it will have a varying gradient. The gradient will change. So here, let's try to see the tan theta. So here, the theta is this. In here, if you draw horizontal line, theta is this. You here, theta is this. So the theta is increasing. If you say theta 1, theta 2, theta 3, you can say that theta 1, theta 2 is greater than theta 1, theta 3 is greater than theta 2. So you can obviously see an increase in the angle. What about tan theta? Tan theta is, it is acute angle, so tan theta is positive. Okay, acute angle, tan theta is positive, gradient is positive. What about the variation? When theta increases, what will happen to tan theta? You know tan graph, right? Tan graph, tan graph tells you about how will tan theta change with theta. So until 90-degree, it will be like increasing. After 90-degree, for obtuse angles, it will be negative and decreasing. Okay, so it's different kind of a thing. You can see for acute angles, this is 90. Angles less than 90 are called acute angles. For acute angles, when you increase the angle, the tan theta will increase. So here theta is increasing, so tan theta will be increasing. Okay, positive and increasing. So what about VT graph? Positive side, you have to show an increasing one. Okay, so you just go like this. Okay, so for this is the answer. Okay, we have to clearly study. the theory. So we only observe thetas and we go for the sign and variation. The sign says acute angle positive, so it's positive. And when theta increases, tan theta will increase, so it will be increasing. Okay, that's it. So now I am going to give you a reverse idea. Okay, not reverse. I'm not going to give you idea. I'm going to give you a question. So what will be the ST graph if BT graph is like this? So now in reverse you are going to do. Can you just think in a different way? Okay, one person is telling, sir, can you explain the tan theta graph? Okay, I will do that. Okay. After doing this, I will do that. So what do you think? Can you draw it in your exercise book? Yeah. Okay, time up. So you should have, like, whenever I tell you to draw, you have to draw. Okay. It is just an electronic screen in front of you. So you can just be like, okay, whatever I do, he will not see me. So that kind of a mentality is not healthy. Okay. So you have to try. Whenever I say try, you should try, because leaving mistakes is the best education. Okay. So you will remember like, yeah, I left this mistake. So I remember it like this. Okay. So leaving mistakes very important. So you should actually seek for the opportunities to leave mistakes. So you make use of these situations. You just try it. Okay. So let's see whether what you have drawn is correct. So first, this is positive, no? So we should have a positive gradient. So the theta should be acute angle. Positive velocity. So theta should be acute because the tan theta for acute angle is positive. And it is decreasing. So here it is increasing. So how will the decreasing graph be? It will be like this. It will be like this. So initially you had a very big theta, and then gradually you can see the graph is becoming a little bit flattened, flat kind of a thing. So theta 2, and here you see only a very small angle is there. So theta 1 is greater, then theta 2 smaller, it is getting smaller. So positive gradient getting smaller. So this is the graph. Okay. So for this is the ST graph. Okay. So you should be able to draw both. You should be able to convert this to this and also this to this. Okay. So this is the theory. We have plenty of time. Okay. Yeah, please study. It will be 1.5 hour class, but I will teach a lot. Okay. That is how revision should be done. Okay. So now one person asked me to explain this tan theta graph. So this graph is somewhat mathematical, okay, but it is helpful for physics. So we usually study that in basic maths. I also teach that. So let's study this graph first. So we remember the tan theta values, sin theta values for some of the angles, right? We remember. So usually we remember for 0. We remember for 30 degrees. We remember for 45 degrees. We remember for 60 degrees, and also we remember for 90 degrees. Okay, you should remember the sine, cos, tan values. So with the practice, everybody remembers usually. So for this, let's write the tan values, tan theta values. So for 0, tan theta is what? 0. Okay. For 30, the tan theta value is 1 over root 2, root 3, sorry, root 3. For 45, tan theta value is 1. For 60, tan theta value is root 3. For 90, tan theta value is infinity. Okay, it's infinity. it's infinity, right? So let's try to plot it in a graph. So I'm going to plot, sorry, I'm going to plot here. I'm going to plot tan theta against theta. So for each theta value, you have to, like, put coordinates like for tan theta, and then you have to join them and draw the graph. So for 0, it's 0. For 30, it's 1 over 2, positive side, no, not negative values. When it comes to 90, it goes to infinity. Infinity means a very big value. It's not a definite value. It's a very large number that we cannot actually, like, say in numbers. We don't actually show it anywhere. It is just a big value somewhere along the axis. So you can't actually show that here. So you draw the graph like this. You stop here and you actually say that it will go like this. That is what you tend to say here. So it goes like this. So you finish the graph like this. Don't make it touch the 90. Then it will give you a different meaning. It will tell you that for 90 there's a definite value. Okay, if it touches the 90, it will tell you for 90 there's a definite value. So don't make it touch. So you draw it like this. For 90 it is infinity. And after that, if you take for 120 degrees, tan theta value is negative. Okay, same as 30 but negative. No, not same as 30, same as 60 but negative. Okay, so when you take for 150, okay, that is again another value. Okay, so it will come like this actually. For tan 180, it is 0 again. Okay, so from for 90 it's infinity now. So here also you have to leave the graph like this. So for 120, okay, 150, 175, you will have negative values. Okay, you will have negative values. And also you can see for obtuse angles which are greater than 90, if we increase the angle, the tan value is decreasing in the negative side. Tan value is decreasing in the negative side. For acute angles, when you increase the angle, the tan theta value is increasing in the positive side. Okay, so you can write a summary like this: 0 to 90 degrees. When theta increases, tan theta increases in positive direction. From 90 to 180 degrees, when theta increases, tan theta decreases in negative direction. Negative direction. Okay. So these are the two main things that you have to, extract from the graph. So this is what you already use. So you don't have to remember everything. Just understand these two. Okay. Try to understand. You have to have the picture of the graph, not just remembering. Okay. Got it? So now you can draw for the coming up examples. So what do you think about this particular history graph? What do you think? Okay, so here did you put the answer? Negative increasing. Excellent. That's what I expected. So here if you draw the angles, yeah, the angle is decreasing, no? And the angle is obtuse. So here it is very wide and here it is getting narrowed up. Okay, so the angle is decreasing in obtuse angles. So you should come from here. Angle is decreasing. So when angle decreases, negative side it increases. When it becomes like 90, that is the infinity value. Okay. So here the tan theta is negative. I mean the gradient is negative and it's also increasing. Okay, it's also increasing. So when you draw the VT graph, it will be like this. VT graph, it will be like this. Sorry, it will be in the negative side, no? Increasing like this. Okay, so what about this one? ST graph. Hooked. Okay, so what do you think? So here also we can observe that it is always obtuse. And it is getting widened, no? The angle is getting widened. So angle is increasing. So when you increase the angle, the tan value is decreasing in negative value. So negative gradient decreases. So negative V decreases. Okay, negative V decreasing. So that's all. So these are the basic shapes that you will encounter. But you will have combinations. Okay, so when you have combinations, you have to like use the theory, everything that you study at once. Okay, okay. So let's move on. Okay. So now I'm going to teach you about the motion under gravity. Okay. So this is a very special kind of a motion that we always encounter in questions. Okay. So you should be able to draw VT graph for it and also ST graph and AT graph for this. Okay. So let's try to draw it. So one person is throwing a particle with the initial velocity v. So ignore, sorry, yeah, it is coming to rest and it is coming back to the original position. Okay, so it will come and go in same line. We show different lines because to see it clearly. Okay, so it is in this direction and this is in this direction. That's to show it. Otherwise, it is going the same line. So there is no air drag. Neglect it. So now, can you draw me? Can you draw VT graph, AT graph, acceleration time graph, and also ST graph? Fine. 1 minute time. Okay, time up. So first, VT graph is very easy to draw because it is a acceleration graph. So we will be changing uniformly. Okay, not uniform velocity. It will be changing uniformly, not a curve. It will be changing uniformly. So initially it will decelerate and come to zero and accelerate in opposite direction. So in this direction, if it is positive, the motion in this direction is positive, and the motion in this direction will be considered as negative. So for this part of the motion, the graph will be drawn in the positive side of the VT graph. For this half of the motion, we will draw the graph in the negative side. Okay. So first of all, let's try to draw this. So this V has a value initially. Okay, we are throwing now, and then it becomes zero. So you will draw it like this. From a value, it will come like this. It is a uniform deceleration, uniformly, not a curve. And then after becoming zero, it is accelerating in this direction. Okay, when it comes down, it will like accelerate, increase the velocity, and it will hit the ground with the same velocity as it was thrown. Okay, so it will like come like this, and this velocity will be this one minus v. Okay, good. So then for ST graph, now you can imagine. Try and draw. So here the positive velocity decreases and negative velocity increases. So do that for the gradient for ST. Okay, gradient of ST is the VT. Let's draw it. Tomorrow we will be finishing linear motion. Okay. Then we will start the forces part. So here the positive velocity decreasing. So here the positive gradient should decrease and it will should become zero. So it will be like this. So here it's zero. Okay, here you can see it is becoming parallel to the x-axis. So the gradient is zero. And then in the negative side, it's increasing. So negative gradient should increase. So here negative gradient should increase like this. Okay, so you draw it like this. Okay, then AT graph. So it is also easy to draw. Listen to me carefully. So we said that the gradient of ST graph gives you the velocity. Like that, the gradient of VT graph gives you the AT, because rate of change of velocity is the acceleration of. So you can use the same theory like you used for conversion of ST to VT. So here also you have to see the gradient of VT graph. So here the gradient is negative, no, for VT graph, negative, obtuse angle, and it's not changing, constant. So gradient of VT is negative and constant, obtuse angle and constant. So acceleration will be negative and constant. So in the negative side, you draw a constant graph. So this shows you the acceleration never changes. It's always downwards. Okay, acceleration never changes. Why? Because the direction of force doesn't change. The force is the one that produces acceleration. No, always the force and acceleration will be in the same direction. Force and acceleration will be in the same direction. So always the weight is pulling downwards. So the acceleration will not change the direction. Okay. Okay, good. Okay. So I hope that you all did well for this question. So now I'm going to give you a list of questions. Okay. So you have to follow this procedure. What I'm going to do is you should send me the answers through email. Okay. So I usually correct the papers of students. So you have to send me through email. I will correct it and send through the email. Correcting in WhatsApp is very difficult. Okay. So note my email address. It's very long because it's created when I was small. So I created a very official kind of a thing. Mahdi Roshan 1997 at gmail.com. Okay. Mahdi Roshan MAHDHYROSHEEN. Okay. EN 1997 at gmail.com. You should send the answers to this. So how do you send? You have to actually send me the scan copy. Okay, you can send photos also, but scan copy is preferred. Scan copy is preferred. If you send me, I will put it to my iPad and I will correct it and send it to your email. Okay, write your name on top of it. I don't know any of you actually. Okay, actually, I never saw you all, so don't worry about your identity. Okay, okay, so these are the questions. So convert the following ST graphs to VT graphs. That's the question. Now write down the questions. Coming to the negative side also. This is straight line, this is a curve. What else is there? Is that all? One like this also. Okay, okay, I will draw it. Yes. You have to draw, copy it quickly, okay? Otherwise, that's all. Okay, that's all for this question. Okay. Okay. Send these to me. Okay. I will erase it. So let's do some questions and finish the class. Okay, so I will do most of the questions from Pesuru, and some easy questions I won't do. Okay, you can do and ask any question at any time. You all know my WhatsApp number, no? Like 0775364 107. So I will answer you. Okay. Sometimes I may be very busy, and at that time I will not be able to answer. So you'll have to wait a bit. Usually I will put a voice note 5364107 077. Okay, so first linear In the linear motion first question we have done. What about the second question? It's a very good question. Okay, I'm reading it. Consider the following statements made about the motion of a particle. Consider the following statements made about the motion of a particle. A statement: velocity of a particle cannot be reversed without changing the direction of its acceleration. Velocity of a particle cannot be reversed without changing the direction of its acceleration. Right or wrong? Okay, I will explain the first one. Velocity of a particle cannot be reversed without changing the direction of its acceleration. So here you should think about some of the instances and examples and decide whether it's right or wrong. So you can actually use the gravitational, okay, motion under gravity here. So we all saw that when you throw mass like this, it will come to the original position. Okay. So here the velocity was initially in this direction. When it returned like this, the velocity changes its direction. So it's in this direction and in this direction, opposite direction. So our VT graph was like this, no? Different directions were there. What about AT graph? Huh? AT graph, we have to draw the gradient of this. So this gradient was negative and constant, straight line. So we drew like this. No, this is how we drew. Already we have drawn this. So you all know that. So here, was there a change in the direction of acceleration? Was there a change? No, not at all. It was always in the same direction. Same value even. Same value, same direction. Negative direction, constant value. But velocity changed its direction. Plus 2 minus transition occurred here, the highest point. Okay, so that statement cannot be correct. That's incorrect. So the B statement, when a particle is projected vertically upwards with a large initial velocity, so you are sending it with like 1000 ms, for example, large initial velocity, its acceleration will exceed the acceleration due to gravity. Will it happen? They are telling large velocity, the acceleration will exceed the acceleration due to gravity. Right or wrong? You can put T if it is true, if it is false. Okay. So yeah, one answer came. Yeah, that is actually false. Okay. So when you are giving, if you want to exceed the acceleration due to gravity, gravitational acceleration is always downwards. If you want to exceed it, you have to give an upward force, because force is the one that produces acceleration. According to Newton's law, you have studied everything, no? This division class, so I'm touching this also. So according to Newton's law, when there is a resultant external force, there will be an acceleration. And the acceleration is always in the direction of force. It's directly proportional to the force. Okay, so whenever you give force only, you will get acceleration. If there is no force, you will not get acceleration. So let's say you are throwing it with the velocity of 10,000 ms minus 1 or 100,000 ms minus 1. Okay, here after you have released it, okay, it is out of your hands, it has gone, nobody is giving force to it, it is released freely, so it will travel under the influence of its own weight. Whatever the initial velocity you give, it will have gravitational deceleration when it goes upwards, because you are not giving the force constantly, no, you have released it. So you gave an initial velocity, that's all right, but it will have a motion under gravity. So it will have g deceleration. Okay, so it will not exceed the gravitational acceleration. The velocity is totally different. The force should be discussed. Okay, when you talk about acceleration, velocity, initial velocity will not affect. So that's false. See, when acceleration of a particle is zero, it must be necessarily be at rest? Is it true or false? You can put your answers. This thing all of you should answer. It should be necessarily at rest. Is it true? Hmm? Is it true? It's false. Yes, it's false. Yeah. Even if it doesn't have an acceleration, without even accelerating, it can have a uniform velocity. No, uniform velocity is zero acceleration, but it is still a motion. Okay, so without acceleration, when acceleration is zero, there are two things possible. One is rest. When something is at rest, that is obviously having no acceleration. I mean, constantly, if something at rest, that is having no acceleration. When something is in uniform motion, that is not at rest. It is at uniform velocity. It's moving, but no acceleration. Okay, the velocity time graph is like this. So it will not have any acceleration, but it will have a motion. It's not rest. Okay, so that is how you decide. Okay, yes. Then what about the third one? So that thing you have to do by yourself. Okay, third one is easy. I will give you some of the numbers. You have to try and count. So fourth one, try. Fifth one, try. Small MCQs. I will not do, but you have to try. But these things I will discuss in the next class. Seventh one, try. Okay. 9. 12. 12 is relative motion. I will teach you. 13, 14, those graph questions. Everything you have to do. 15. Okay. 16, 17. Okay. Everything you have to do. 18 is okay. 19 is something that you have to do. 21, 19, 21, 22. Okay. Do them. Okay. That's it. Okay. So let's finish the class. If you have any doubts, you can ask me now, right now. I will check the chat also if there is any doubt. Then the B part again. So B part is what? What did it say? B part says that. B part says that. B part is yes. Yeah. Yes. When a particle is projected vertically upwards with a large initial velocity, so you are just giving large initial velocity, but still it is under the influence of the gravity. No, the only force acting on the object is mg. It will be having a velocity, that's fine. But if you use F is equal to ma, F will be this mg downwards. So when you use upwards, it's minus mg is equal to ma. So A is equal to minus g. So this will be the deceleration. Okay. So this cannot be changed. But if you constantly give a force, then you can exceed. If you can actually give the adequate force, you can exceed the gravitational acceleration. But just releasing it, it is now not in contact with your hands. It is not getting any force. You have released it. Only thing that it has is velocity. With velocity, it will not exceed. Okay. So you have to write an explanation there in your notebook. The velocity will not affect the acceleration. There should be a constant force. Okay, not a constant force. A force that can overwhelm the weight is mg. The force that can overwhelm the mg will exceed the gravitational acceleration. Otherwise, it will not. Okay. So let's see. Are we supposed to answer Esuru questions or Esuru question also sent as mail? No, that's not necessary. Okay, you don't have to answer them. Esuru one, the graphs you have to answer and send. everyone do everything, and if you have things to ask me through WhatsApp. I can. Okay, I'm just going through the names. So it's mostly girls, right? Only one boy is there. Okay, good. Thank you. Let's meet next in the next class.